Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 1, Lesson 7 on exponent review. Now we've already seen some exponents here and there, but exponents are a very, very important idea in math because, as we know, they represent repeated multiplication. So let's do some basic review on what exponents mean. All right. Exponents mean repeated multiplication, just as multiplication means repeated addition. Right? And by definition, if n is a positive integer, so like 1, 2, 3, etc., then x raised to the n power, or x to the nth, as we might say it, would be x times x times x, etc., n times. I almost said 7 times, but that's only true if n's actually equal to 7. All right? And it's important to never forget what an exponent represents. Because if you had something like x plus x, you wouldn't want to say, oh, well, that's x squared, right? Because it's not. That's just 2 times x, all right? So let's make sure that we really understand exponents with some very, very basic work on them. Exercise number 1. Write out what each of the following exponents means as an extended product and find its value. All right. So I would say this, 2 with an exponent of 4, I'd say that that's 2 to the 4th power, right? And what that means, by definition, is it means 2 times 2 times 2 times 2. And that's what I mean, by the way, when I say an extended product. Now, how do I actually figure that out? Well, I could actually do a little bit of associative property of multiplication and kind of group it like that, in which case 2 times 2 is 4, and 2 times 2 is 4, and 4 times 4 is 16. Of course, one of the unfortunate things about exponents is any exponent other than 1 or 2 means that you're going to have to do multiple calculations. So, letter B, what's nice, is I've got 3 to the 2nd power. Another way of saying that is 3 squared. We call it that, remember, from middle school, because 3 to the 2nd power, or 3 squared, would give us the area of a square that has a side length of 3, right? So 3 squared. All right, now 3 squared, an exponent of 2 is one of the most common that you'll see out there, is just the number times itself. So 3 times 3, which is equal to 9. Okay. One last one. I'd like you to do letter C on your own. 5 to the 3rd power, also known as 5 cubed, for the same reason that we call that 3 squared, we call that 5 cubed because 5 to the 3rd power would give us the volume of a cube whose side length is 5. Pause the video now, write 5 cubed as an extended product, and figure out what its value is. Try to do so without your calculator. All right, now very big exponents we will often do with calculators because the results can get very large very quickly. But 5 to the 3rd we should still be able to do by just writing out the extended product, 5 times 5 times 5. That's not 5 times 5 times 5. Here it is, 5 times 5 times 5. Again, I'm going to do a little bit of associative property. I'm going to group those two together. 5 times 5 is 25. And then 5 times 25 is 125. It's very important to be able to do small powers without a calculator and very quickly, especially when you're squaring things. As well, it's pretty important to be able to cube numbers, relatively small numbers. You don't need to know how to do, or you need to know how to do, but you don't certainly want to be doing something like 13 cubed in your head, or maybe even on a sheet of paper. For that, we would use our calculators. And we are going to eventually be breaking the calculators out, just not in these introductory lessons. Let's move on and get some more work with exponents and what they mean. Now, variables and expressions can also be raised to exponents as well. We need to be able to interpret what the exponent represents, or what the exponents represent in terms of products. So let's take a look at exercise number 2. Write out each of the following terms involving exponents as an extended product. Carefully consider your order of operations and remember that exponents come before multiplication. All right? So, this is very similar to what we did in the last exercise. The big difference is we're not going to come up with a final answer in terms of a number. I just want to write out what this means. And let's start with the simplest thing we can, right? x cubed, x to the third. All that means, when you see it, you have to know that that means x times x times x. That's all I'm looking for you to do in these exercises. And look, this is only useful in terms of really understanding what the exponent is telling us. It's saying, oh, I'm going to multiply x by itself 3 times. Now, we can certainly get more complicated things like this, where we have x squared times y to the fourth, in which case, right, what we've got is x squared, which is x times, whoops, that is way too big, x times x, and then y to the fourth is y times y times y times y. That's it. X times y times y times y times y. That's what all that expression means. Now let's take a look at one that's a little bit trickier in letter C. Here I've got 2x, but notice that's inside of parentheses, and I've got 2x to the second, 2x squared. All right, and it's important to understand that because the 2x is in parentheses, that what this expression means, written out, is 2x times 2x, or without the parentheses, 2 times x times 2 times x. All right, now we could rewrite this in also different ways, okay, by using the associative and commutative properties of multiplication. But all I want us to be doing right now is understanding what these expressions are telling us in terms of extended products. So pause the video now, and why don't you go ahead and try to do D, E, and F. Just write them out as extended products. Don't worry about combining anything or multiplying anything out. Just write out what the exponents are telling us. All right, let's launch into all 3 of them at once. Let's go to the board. Letter D, 4x to the fourth times y to the third, or y cubed. Now that 4 is not being raised to any exponent other than 1. So it's certainly not being raised to the 4th power, or it would be in parentheses. So 4 times x to the 4th is just that, then times y times y times y. That's it. Lengthy, but that's it. Now in letter E, we have 9x squared cubed. We have like an exponent within an exponent. But keep in mind that we want to look, at least initially, at that 9x squared as a single thing, right? See the structure in that expression. It's a single thing, right? So I get 9x squared times 9x squared times 9x squared, and then I can further expand that by doing 9 times x times 9 times x times x. Hey, my mystery red pen came out and visited today. 9 times x times x. Woo! That is one lengthy answer. But again, what I'm looking to do here is just understand what's going on. Let's get rid of the magic red. And finally, negative 4x to the third squared. Same idea. First, I want to look at the negative 4x cubed as being a single thing. So negative 4x cubed times negative 4x cubed. And now I can look at that as negative 4 times x times x times x times negative 4 times x times x times x. And I just managed to fit it in. All right. So, we've got this just basic idea of what our exponent's telling us. And each one of these expressions, right, can be written in a much longer, more horrible way by writing them out like this, right? But if we ultimately had to evaluate this, let's say we were stuck on a desert island without a calculator, I think we'd be worried about a little bit more than just algebra. But let's say we were worried about algebra, right? Then we might want to write them out kind of like this in order to be able to easier evaluate them. Okay, so let's keep going, right? Now, one of the cool things about exponents is that they follow predictable patterns, and you've learned about these things in previous courses. They're called exponent properties, sometimes called exponent rules, depending on the textbook that you're using. We might call them both. Anyway, they follow these predictable patterns known as exponent properties or rules, right? So let's take a look at exercise number 3 to see the most basic exponent rule that's out there. Let's take a look. Write each of the following expressions as an extended product, and then express each in the form of a single base raised to a single exponent. Do not evaluate the numerical expressions. All right, let's do letter A together and understand what we're getting at here. All right, in letter A, we've got 5 to the second times 5 to the third. Well, 5 to the second is just 5 times 5, and I'm going to leave that in parentheses, times 5 to the third, that's 5 times 5 times 5. Now, the associative property of multiplication says, well, I don't really need the parentheses there because it's all multiplication. And now what I see is I've got 5 to the 5 times 5 times 5 times 5 times 5, etc., right? I think I have one too many 5s there. I do. It's good to get rid of the extra 5 that I don't need. And that's then 5 to the fifth. So 5 to the second times 5 to the third is 5 to the fifth. Let's do letter B together as well, and then we'll have you do letter C on your own. Letter B, we have x to the fifth times x to the second, so that's x times x times x times x times x. Whew. That's x to the fifth times x, right? And now what do I have? Well, I've actually got x to the seventh, right? I've got 7 x's that are multiplying each other. So finally, do letter C on your own. Take just a few minutes, if even that, to figure out what that is equal to. All right, well, simple enough. The one thing that's a little bit confusing here is I've got just a y. Now keep in mind that if a variable is written that it doesn't have an exponent, right, that exponent's really equal to 1. So this is really y to the first, right? Just one y, essentially, right? So I've got y to the first times y times y times y, and that's y to the fourth. All right, so that's really a y to the first. So what's the pattern, right? And that's really what we're getting at in exercise 4. We've got 5 to the second times 5 to the third is 5 to the fifth. Right? We've got x to the fifth times x to the second is x to the seventh. We've got y to the first times y to the fourth. Y to the third is y to the fourth. So what is the rule? What is the property? Exercise number 4. What was the pattern from exercise number 3? Give a generic rule for what happens when we multiply two terms that have the same base. And let's talk about this for a second, right? In any expression that has exponents in it, you have the thing that's being raised to the exponent, in this case that's x, that's called the base. And then you have the exponent itself, and that's called the power or the exponent. So what is the deal? If I have x to the a times x to the b, what do I have in here? Pause the video now and see if you can fill in, the ending of this property or rule. Well, notice, in each case up here, what we ultimately did, or what we ultimately had as a result, was the base, the common base, raised to a power that was simply the sum of the two powers. And that should make all the sense in the world, right? If I have x to the a times x to the b, that's going to be x to the raised to the a plus b. It might almost seem like you should have x raised to the a times b. Right? Oh yeah, I'm multiplying things together, so why wouldn't I multiply the powers? Except the powers are simply telling you how many times you're multiplying x by itself. So I multiply x by itself a times, I multiply x by itself b times, which means overall, I've multiplied x by itself a plus b times. And we want that exponent property because, quite frankly, we don't want to have to do this. Right? We don't want to have to write all of this out in order to simplify these kind of products. So let's see if we can use this exponent property to do some additional work. Exercise number 5. Quickly write each of the following products as a single base raised to a single power. All right, simple enough. Now, by the way, it doesn't matter whether the base is a number or whether the base is a variable. Remember, all variables are numbers that you don't know. So if it works for a number you don't know, it's going to work for a number you do know, and vice versa. So let's take a look at letter A. Okay, in letter A we have 10 to the fourth times 10 to the ninth. Our exponent property tells me that should just be 10 to the 4 plus 9, which is just 10 to the 13th. There's not absolutely anything critical in terms of writing this intermediate step. If you know the property, you could certainly go right from 10 to the 4th times 10 to the 9th down to 10 to the 13th. But please note, right, the base stays the same. It's not like I multiply the two 10s together and get 100 to the 13th. I just get 10 multiplied by itself 13 times. Why don't you go ahead and do letter B and letter C? These should be pretty fast. All right, let's go through them. Simple enough. Now again, this only works if the base is the same in each case, which in these problems is, right, here we've got x, x, and x. So x squared times x cubed times x to the 4th. We're just going to add those exponents, right? 2 plus 3 is 5, plus 4 is 9. So all of that is going to be x to the 9th. Likewise, here we've got y to the 2nd times y to the 6th. That's going to be y to the 2 plus 6. And that's going to be y to the 8th. All right, it is so critical that when you see something like this, you know not only that you should be adding the exponents, but you should know why you're allowed to add the exponents, right? That's why we did all those extended products in the first place, was to give you the why, not just the how. Understand the why, and the how will just follow from it. If all you remember is the how, that could be quick in, quick out, and then you forget it by the time the next test comes along. So let's keep going. All right. Now, we want to be able to simplify more complicated products that involve exponents. All the manipulations we do with variables and numbers can be justified using one of the properties we've learned. Remember, we've learned things like the associative property, the commutative property, the distributive property, and I'm going to even throw in the exponent property number 1, right? We now have sort of like 3 things we're working with. Those 3 properties of real numbers with addition and multiplication, plus we've got the exponent property number 1. So let's take a look at exercise number 6, where we simplify a more complicated product, right? Let's take a look. Exercise number 6. The steps to write the product 5x to the 3rd times 2x to the 7th in simplest form are shown below. Write the property that justifies each step. All right, so let's talk about these in turn, right? We've done these kind of justifications before, right? I've got 5x squared times 2x to the 7th, and I've rewritten that as 5 times 2 times x to the 2nd times x to the 7th. And again, I know that that's a little bit small on the board. Think about how it is for me. I can barely see, right? So what allows us to basically take the x squared and the 2 and flip-flop them? What property does that? Well, it's the commutative property of multiplication, right? The commutative property of multiplication says anytime we've got a product of 2 things, like x to the 2nd and 2, we can flip them to make that into 2 times x to the 2nd. So that's just commutative for multiplication. Multiplication. Right? It's the commutative for multiplication. Now, in the next step, right, we've taken this expression, we've just repeated it down here, and we've now said, well, you know what I'm going to do? Even though order of operations tells me I should be evaluating the product in this direction, I'm going to group those first 2 things together, and I'm going to group those second 2 things together. What property allows us to group different parts of a product together? That's the associative property of multiplication. I always have to think about how to spell that word. Associative for multiplication. It's probably not a surprise that we're not getting anything in terms of addition here, given that all we're doing is multiplying things together. And finally, in our last step, right, we've got these 2 things. We've taken the 5 times 2, we've made it into 10. There's no property for that. That's just what 5 times 2 is. And then we've got x to the 3rd, times x to the 7th, which gives us x to the 10th. And that is simply our exponent property number 1. Yeah. Right? Now, we need to be able to take a term like 5x to the 3rd and multiply it by a term like 2x to the 7th very quickly. but we also want to know why every step works the way it does, okay? So let's get some practice on this in our last problem. Exercise number 7. Rewrite each of the following equivalent expressions in simplest form. All right, so let's talk about this a little bit. I'm going to bring it up to the top of the sheet, right? These are all a version of the last problem that we worked on where we were justifying all the steps. So let's do letter A together. Here I've got 2x to the 7th times 8x to the 5th. Now I can rearrange that so I have 2 times 8 times x to the 7th times x to the 5th. I can then think about it by grouping my 2 times 8 together and my x to the 7th times x to the 5th together. And of course 2 times 8 is just that number we call 16. X to the 7th times x to the 5th, I'll add those exponents and I'll get x to the 12th. Now, of course, a lot of students will eventually just say, well, I'm going to take the normal numbers like 2 and 8 and I'm going to multiply them together. And then I'm going to take the two things with variables in them and I'm going to multiply them together and add the exponents. And that's fine. But keep in mind that what we are doing is we're using the commutative property of multiplication to kind of reverse the order of some products. And then we're using the associative property of multiplication to be able to say, well, look, I want to group the 2 times 8 together and group the x to the 7th times x to the 5th together to get that answer. All right, all that being said, the remaining 3 problems are very similar. Maybe there's a little twist in letter D, but I bet you can figure that out. Take a little bit of time now and try to work through each one of those 3, and then we'll go through them all. All right, let's do it. Letter B, negative 4n cubed times 2n squared. I'm going to group the negative 4 times 2. I'm going to group the n cubed times n squared, and then do a little separation here. Negative 4 times negative 2 is negative 8. N to the 3rd times n to the 2nd. I'm going to add those exponents and get n to the 5th. Now, this other letter C might be a little tricky because that 5y isn't in parentheses, but keep in mind it's still 5 times y times 3 times y squared. So again, I can group the 5 times 3 together. I can group the y times y squared together. 5 times 3 is 15. Y to the 1st times y to the 2nd is y to the 3rd. So I just get 15y to the 3rd. And finally, in that last problem, I've got negative 6t cubed squared. Well, the key here is to remember, right, that this is just the same as negative 6t cubed times negative 6t cubed. That's what it means to square something. I can now group the negative 6 times negative 6 together. I can group the t cubed times t cubed together. Negative 6 times negative 6 is 36. T cubed times t cubed, watch that, is t to the 6th. Be so easy to say t to the 9th, wouldn't it? To be like, oh, I gotta square the 3 as well. But nope, 36 t to the 6th, right? And it is absolutely critical that you're able to do this kind of skill because it's going to get wrapped up in much more lengthy problems. I'm not going to call them difficult, but lengthy problems in future lessons. So let's wrap this one up. All right, today what we did is we reviewed exponents. We reviewed just the basic notion of them. What do they mean? What do they tell us, right? And a great way to get at that is by writing out those extended products. Anytime you're confused about what an exponent is really talking about or an exponent property or anything, write it out. Write it out as an extended product. Exponents just mean repeated addition. Now, using that idea then, we developed that very important exponent property number 1, i.e., when you multiply two quantities that have the same base, right, then you add their exponents together. That is a critical idea in algebra, and we're going to see it a lot as we move forward. I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.